In this tutorial, we're going to recreate the Instantiate prefab script using Bolt. If you aren't using Bolt, feel free to skip ahead. I'm going to be using both Bolt and C# in this tutorial series. Here, I have the start of our Unity sandbox. It's a simple scene just with Unity primitive 3D objects. I should say that Bolt is already set up. If you need help with that, I'll put a link below. Create an empty game object. I'm putting mine inside this cube. Let's call it Ball Maker. Click Add Component and add a state machine. Click New, and I'm going to save mine in a folder called Macro. In the flow graph, right-click on Start and choose Make Self Transition. Double-click on the transition node and right-click, add a unit, add on Enter State. At the top corners of the flow graph, you can click on an icon which will bring out the panels for the graph inspector and our variables. Select on Enter State and check out the graph inspector. There you can see there's a toggle for coroutine. Coroutines are functions that have the ability to pause execution and then continue again where things left off. That's exactly what we want for our script. You can also see the variables panel. We're going to make two scene variables in the Scene tab. The first variable is going to be the wait time before another ball appears. So let's call this variable wait between balls. And then let's make that an integer. Let's add another variable because we're going to add random spin to the balls. So type random torque and make that an integer as well. Back to the flow graph, right-click, add unit, and type wait 4 seconds. Connect the on-enter state to wait, and then wait to trigger transition. Click and drag the wait between balls variable into the flow graph and connect it to the delay time. Click back to the top state of the state machine. Double-click on Start. I've deleted Update and On Exit. We want this flow to happen on Enter. On Enter, we want a game object. Let's add a unit, game object, instantiate. I have a prefab of a sphere with a rigid body on it from the last video. I'm going to drag that into Object. We want the ball to appear at the position of the ball maker. So let's type transform get position. It also wants a quaternion value, and rotation doesn't matter, so let's just keep it 0, 0, 0. I want all the balls to be nested in this ball maker object, so for parent, put self. We also want a slight random spin to each ball. Add a unit, type rigid body, add torque. We want the add torque unit with X, Y, Z, and mode. Having a unique spin for each ball adds some unpredictability for our physics lab. Let's add 3 random range units. You can make one and press Ctrl-D to duplicate the other nodes. We're making it so that each ball can spin any direction. That means we're going to need a positive value and a negative value to spin the other way. First, let's grab our random torque value and plug it into max. I have mine set at 15. Then, let's multiply this value by -1 and plug it into minimum. We also want these values to change every time this flow happens. The on-enter state flow will go into Instantiate, through each random range unit, and then to add torque. Add torque also needs our object from the Instantiate unit. Last, we want to add a destroy game object unit with a time variable. Feed the Instantiate object into the destroy unit. And I'll put 10 seconds. Press play and you'll see the balls generating, and each one will have its own spin. An amazing thing about Bolt is you can dynamically see the script working. Look at the output of the random range values and how they change with each ball. Okay, that's it for this video, and like I said, I'm going to keep using C# and Bolt for this Unity Sandbox tutorial series I call Kinetic Lab. Alright, thanks!